Hello, everybody. Welcome to section 2.6. This section is on transformations of functions. So let's go ahead and get started by looking first at the different kinds of transformations. So kinds of transformations. And just to be clear, by transformations, I mean, we're taking a function, or we're going to be looking at its graph a lot. And we're going to be looking at how, when we make changes to the function's algebraic expression, how that reflects on changes in the graph. So the three basic kinds that we'll be looking at are translation. So shifting up or down or side to side. Reflection. Oops. And lastly, we'll be also looking at scaling. So that's shrinking and stretching, etc. Okay. So first things first, let's start off with translation. So to look at translation, let's suppose we have, let's say, a positive number C. So we want it to be positive, so we want it to be strictly greater than 0. And some function that we're going to play around with, let's call it f of x. So then here are the translation rules. First, so if we do f plus c, so outside of the function, so the whole function plus a number, that's going to end up looking like a shift in the graph up by c units. Okay. If we look at, f of x minus c, that's going to be a shift in the graph down by c units. All right, cool. But how do we get left and right? Well, if we look at f of x plus c inside the function, so we're evaluating the function at f plus c, that will be a shift in the graph to the left. By c units. And similarly, you guessed it, x minus c inside the function is going to be a shift in the graph to the right by c units. Okay, so already we've only covering one kind of translation. There's already a lot of rules. There's 4 of them, in fact. But let's look at them and let's break them down and let's look at examples. Let's try to get a concrete idea of what this means. So let's let, for our base function, so consider, let's look at something simple. Let's just do f of x equals x squared. So simple parabola, right? I'm going to graph it, even though we've seen the graph of it already, so that we can sort of compare the original graph to our translated graphs. So if we plug in these points, they go to 4, 1, 0, 1, 4. And if we looked at a graph, x-axis, y-axis, 2, 3, 4, 5. Our parabola, whoa, wow. Sometimes my mouth just decides to do its own thing, even when I try to tell it to say a specific word. The parabola will look like this if we plot our points. And then we connect them with our parabola line like that. Okay, cool. So first off, let's look at, let's say we want to shift it down by 2 units, for example. So let's do a shift down by 2 units. Okay, and so if we remember from our rules, that means that we're going to take our f of x and we're going to subtract 2 from it outside. So if we look at that in, our function, that's going to be x squared minus 2. All right, now what we're going to do is let's graph. We will graph it, but first let's look at the points when we plug it in. So we'll do the same ones, -2, -1, 0, 1, and 2. And then if we plug it in, this becomes -2 squared minus 2, which you'll get as 2, I believe. And then this one's -1, 2, is 2. That one is, sorry, brain fart. That one's -1. This one is 0 squared minus 2. That's -2. This one's 1 squared minus 2. That one is 1. And this one is 2 squared minus 2, which is, again, is 2. Or sorry, that one's -1. There we go. Okay. And now if we graph these, coordinate plane. If we plot these points, so we have -2 and then up to here. And then we've got -1, -1. So that will be here, then 0, -2, and then kind of the same thing on the other side like this, and then connect them with our lines. And we see that we actually do have something shifted down by 2 units. So this is our original graph. And then if you imagine that you just move it down by 2 units, we get our thing. Because if you draw our blue parabola here, it is indeed shifted down by 2. Excellent. Okay, so our rules so far, they're holding up, they're making sense. So let's try a different one. Let's say we want to shift left by, let's say, 1 unit. So according to our rules that we did above, that means that we do f of x plus 1 inside the function parentheses. So if we look at that, and when we plug it into the function, every time we see an x, we're going to write down x plus 1. So what that looks like is we have x plus 1 squared. And if you expand that out, that becomes x squared plus 2x plus 1. All right, let's look at this in terms of our points. So we'll do -2, -1, 0, 1, 2, as usual. All right, so if we plug in our points, we'll be doing f of -2 plus 1 is -1. This will be f of, or actually this is going to be confusing. Let's do it this way instead. Sorry about that. Let's just plug it in to this thing right here. So we'll have -2 plus 1 squared, -1 plus 1 squared, 0 plus 1 squared, 1 plus 1 squared, and then 2 plus 1 squared. And if you do the math out for these, I believe you'll get something like 1, 0, 1, 4, 9. All right, and then if we graph this with my dazzling artistic ability here, so -2 goes to 1, so that's going to be right about here. Then that one is 0, and then 0 we're at 1 again, and then at 1 we're at 2, 3, 4, and then at 2 we get all the way up to 9, which is going to be somewhere around here. And so if we connect these dots like so, we get a parabola. And that's good because we see it is shifted over to the left by 1 unit. So if we go back up here to our original graph, that one, its vertex is at the origin, right? And if we move it over 2, or sorry, move it over 1, we get this one. So that's good. So left by 1 unit. All right. Transformations, though, aren't just themselves in isolation. Oftentimes, we'll be looking at them together, working together to form a function. So let's see an example of that. Let's say we wanted to shift up by 1 unit and right by 1 unit. So according to our function rules, the shift right by 1 unit will be x minus 1 in the parentheses, and the shift up by 1 unit will be plus 1 outside of it. And so if we look at that in our function, that's x minus 1 squared plus 1, which if you FOIL this out and simplify, blah, 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 you get x squared minus 2x plus 2. So let's look at our points as usual. We'll do f of x minus 1 plus 1. So we get negative 2, negative 1, 0, 1, 2. And then I'm not going to do the arithmetic for these, but if you plug in these points to this function, you'll get 10, 5, 2, 1, 2. So then if we look at this on our coordinate plane, make this one a little bit bigger maybe. I think about drawing these out beforehand sometimes, but then I'm like, no, because then I'll be going too fast. So I draw these out as I did the lecture to try to slow myself down, to give yourselves maybe time to pause, take a break, maybe ignore me as per usual. Okay, let's point these let's plot these points. So negative 2 goes to 10, so that's all the way up here. And then negative 1 goes to 5. 1, 2, 3, 4, 5. Right here. And then 0 goes to 2. And 1 goes to 1. And then 2 goes to 2 again. Okay, you can kind of see the parabola shape already. Kind of pass through this point right here like that. Okay. It's a very sketchy drawing, but let me try one more time. There we go. It's much better. Okay. So that's what a parabola looks like, which is good because if you remember, our original parabola was centered at the origin right here, right? So we do indeed have shift right by 1 unit, and then a shift up by 1 unit. All right, excellent. Okay, so for this part 1, let's cover the second topic as well. Let's talk about reflection. And the reason I'm doing that is because it'll turn out that scaling is actually more complicated than translation and reflection. So it'll be good to look at that independently. But as far as reflection goes, let's suppose we have f of x, and reflection's pretty simple. It's only got 2 sort of rules. If you have negative f of x, so if the negative's on the outside, we're going to reflect across the x-axis. And if the negative is on the inside, we're going to reflect across, you guessed it, the y-axis. Okay. So for this one, let's consider maybe something a little more complicated so we can really see what these reflections are doing. So let's look at like f of x. Let's see the absolute value of x minus 1. And so if we look at a graph of this first, so we can compare it later. Let's do our usual points. And so if we plug these in, we get absolute value of -2 minus 1. That's going to be the absolute value of -3, so that's 3. And then absolute value of -1 minus 1 is going to be 2. 0 minus 1 is going to be 1. 1 minus 1 will be 0. And then 2 minus 1 will be 1 again. So if we look at a graph of this, x, y, all right, we'll plot these points, go -2 up 3, -1 up 2, 0 up 1, 1 is 0, and 2 is 1 again. So that'll look like this. There's our V. Okay, so now let's look at some reflections. Let's just do standard reflect across the x-axis. So if you remember from our rules up there, that means that we're going to do a minus sign on the outside of our function. And so if we look at that in context, that's minus absolute value of x minus 1. So let's look at our points. Negative f of x. Standard stuff. All right, and we plug these in. You're going to get negative f of -2. That's going to come out to -3. Negative f of -1. That's going to come out to -2, and so on and so forth. And if you do these calculations, you're going to find that you get -1, 0, and 1. So if we graph that, I'm sorry, this should be -1. Now if we graph this x, y, we make our little tick marks. Okay. All right, so -2, -3, that's down here. -1, -2, it's right there. 0, -1, 1, 0, and then 2, -1. There's our V shape. And look at that. That's good, because our original one looked like this, if you remember. Right? And so what's happened is we have reflected across the x-axis. All right, perfect. So now let's look at reflection across the y-axis. So if we remember from our rules up there, that's going to be a negative sign inside the function parentheses. So if we put that in context, that'll look like -x minus 1. And so if we do our points, oops, that needs to be -x. Let's actually plug these in. So this will be -2 minus 1. That will come out to 1. And then -1 minus 1. That will come out to 0. And then -0 minus 1. That's just going to be 1. And then -1 minus 1 is going to be 2. And then -2 minus 1 will be 3. And so if we graph this, all right. So let's plot our points. -2 up 1, it's going to be here. And then -1, 0, 0, 1, 1, 2, and 2, 3. And so there is our line. And excellent. That's good, because if you remember, our original thing looked like this. And if you imagine flipping it over the y-axis, everything that's on the right of it goes to the left, and everything on the left goes to the right. So that's good. So we actually do have reflection about the y-axis. Excellent. Okay. So that was reflection along with translation. Those are 2 out of 3 of the basic function transformations. Function transformations can be tricky because there's a lot of rules to play with, but just practice with them. If you do enough playing around with them, enough graphing, playing with graphing calculators, looking at what changes when you change certain things, you'll kind of get a feel and a sense of them, and things will get faster and easier. So that's what I recommend doing. So keep working on the homework, and I hope to see you in office hours.